Hello, everyone. Welcome to IS 300. Today we're talking about virtualization technology, and this is Domain 8 in the Cloud Security Alliance white paper entitled Security Guidance. In this chapter, we talk about an introduction, an overview, and some recommendations. Virtualization technology is critical for enabling cloud computing. Without virtualization, there is no cloud computing. It converts infrastructure into pooled resources. That infrastructure includes networking, computing, storage, and containers, as listed here. It abstracts the resources from the underlying physical assets and allows you to create a virtual machine, and that virtual machine then is an abstraction of the underlying hardware and or software. You can virtualize almost anything from the entire operating system to a network, anything that can be created and or monitored in terms of technology can be virtualized. And again, without virtualization, there is no cloud. There are two additional layers for security. You have a hypervisor, which gives you the ability to secure the virtual machine itself, and then you have controls to secure the virtual assets. For compute virtualization is the running of code, including an operating system, an entire operating system, from the underlying hardware. Instead of running directly on the hardware, the code runs on top of the hardware, gives you more flexibility, and it is almost bulletproof in terms of downtime. If the machine goes down, the virtual machine goes down, you can simply restart it, redeploy it, re-image it. There's all kinds of flexibility as a result of virtual machines. The provider is responsible for isolating all of the processes, everything that's in memory, anything that's in a container. It should not be visible from one virtual machine to another. And the underlying infrastructure has to be protected, just as in the traditional environments. The cloud users now have the ability to configure their virtual machines. They have the ability to monitor and log. They have the ability to manage assets and to ensure deployment of only secured configurations that have already been patched, that have been updated. You get the new virtual machine with the new patch on it, and you're good to go. Monitoring and filtering. There is a restriction on using things like packet sniffers, so you cannot look at the raw data. You can, as the virtual machine or the user, you can only collect raw data if you collect that raw data yourself, which will generate additional overhead. Here's a nice diagram. On the before side of this diagram, it shows the physical network, which is connected to two servers, server 1 and server 2, in a traditional network environment. With virtual machines, you have the underlying physical network, and then you have all these different virtual machines on server 1. It could be server 2, server 3, server 4, and so on. Multiple virtual machines is the idea, and one underlying physical network. Cloud computing allows for remote management, for securing the management plane, which we know is the way to configure and monitor and manage virtual machines. The metastructure, making sure that it is protected, that is critical. You can, with a few APIs, a few well-positioned APIs that are unauthorized, can destroy an entire network. So it is important to secure the management plane and to avoid APIs and API calls. And it is also important not to put the password embedded inside of the API. The provider responsible for detecting and preventing attacks on the underlying physical network and on virtualization platforms. The provider is also responsible for securing the infrastructure and configuring it properly. It is a good idea to disable packet sniffing and to enable firewalls. This is the same whether it's a virtual network or a traditional network. The users are responsible for configuring their own deployments, just their deployments. Ideally, you want to use a template. So you create an image, and then you can deploy and redeploy that image. You can update that image you can create a baseline and then use the template to keep your updates current and your patch management and things like that. Encryption is important, and you must encrypt also the physical layer as well as the virtual layer. Container, as we talked about before, is a simple executable code that can run an application. It should be secured just like the underlying physical infrastructure, and it extends the operating system. An image should be in a secure location with the appropriate controls. Build the security into those tasks and codes that are running inside that executable, and do not grant too much network access. Secure the hypervisors. Implement patch management. Isolate virtual machines. Implement perimeter security defense at the physical level as well as any virtual layers. Isolate the virtual network so that there is no cross-contamination. Make sure that network monitoring and alarming and things of that nature are in place. Be sure that the contractual agreements, service level agreements, as we'll talk about soon, have been defined properly. Encrypt all of the underlying physical storage. Isolate the encryption from the data management functions, and the users should make sure that the provider has given them a definition of any potential security gaps and the authority to properly configure their own virtual environments using best practices.